Hello friends, welcome to another video, and in this video we will see one more advanced coding question of TCS NQT. So this question is similar to a question that I have already discussed where we had to find the maximum amount of gold coin that we can collect. If you can remember, you can go through the playlist. So there in simple word, there we had to find the length of the maximum subarray with sum exactly equals to k. So that was that question, and this is a similar question. There is just a slight difference that here we have to find the length of the maximum subarray with sum less than k. So this is the question in this case. Okay, so we will see. So this question is very important for all of you. Try to learn this, and here we will use one algorithm which is sliding window, which is very popular and very important. So there are chances then that it can be repeated. You can get similar question as well. So try to learn this. Okay, so here we will discuss the code in C++, and I have already made the same video with Java also and Python also. So go there and try. So this is the question. So you can pause the video and try to read the question. So I hope all of you have gone through the question. So question is basically like this. So there is a person named Bob, and he has k amount of money, and he wants to put a bet on different horses. But the condition is that he can put the bet on different horses in a continuous manner, and there are n horses. Each horse will be having some money that you require to put a bet on that horse. So basically in simple word we have to find. So this line is basically a conclusion. Where is it? Yeah. Can you please find the length of the maximum continuous sequence of horses on which Bob can make a bet, and remember he will invest money less than k. So make sure you see this less than k. Okay, so let me try to make you understand the question. So this is like this. So the input will be given like this. First line of input, this will be n, that is number of horses is there, and which is length of the array also. This is k, this is the amount of money Bob has. So in this case he has 100 rupees. Now these are all the horses and the amount on that horse. So here if you want to put bet on the first horse, you need 30 rupees. Here you need 40 rupees, 50 and so on. Now Bob, what he will do, he has to make bet on continuous horses. So let us say if he start from first horse, then he has to continuous. Okay, so let us try to understand the question. And we have to find the maximum continuous horses that he can put bet on. We have to find that maximum. Okay, and we will return that. So let us start from here. So let us say that he put bet on first horse. So 30 rupees he has spent. Now still he has some money, so he want to do maximum. So still then he will move further. So now he can see that okay, 30 plus 40 is 70, which is less than the amount of money Bob has. So he can put a bet on both the horse. Now he will think, okay, if I try to make a bet on third horse, is it possible? So he will calculate. So already he has spent 70 rupees. The moment he will include this horse, so 70 plus 50, which will be 120, and he has only 99 rupees. Although 100 rupees, but we have told you that he can spend less than k. So less than 100 is 99. So up till 99 he can go. But if he include this horse, he needs 120 rupees. Okay, it means it is not possible. So starting from first horse, he can only go continuously up to second horse, and there is no more chances that he will move further. So this is one possibility. So up till here, what will be the length maximum? 2. Okay, so now he will do what he will think that okay, let us start from second horse and see how far I can go. So he will start from here, 40 rupees plus 50, 90. Up till 90 he can afford, but the moment he will try to move to third one, or fourth horse. So 90 plus 20, 110. He does not have that much money, so he will stop here. So in this case also the length is 2. Okay, so still it is 2. Now he will think, okay, let us start from third horse, then see how far I can go. So he will start from 50. So 50, then he can afford plus 20, 70, he can go plus 20, 90. Still he has chance because he can go up to 99. So up till here he can afford. Now the moment he will try to move here, so the total will be 50 plus 20, 50 plus 20, 70 plus 20, 90 plus 10, 100. So if he will try to include this horse, he need 100 rupees, but he has only 99 because less than k, so 99. So he cannot include this horse. So in this case, what is the maximum continuous? 3. So now the answer will be 3. In this way he will try all the combination, and you can see yourself. In this case the answer will be 3. Okay, maximum will be 3. So in this case output is 3. So this is the question all about, and we have to make this length maximum. So there is no other case you can find where you will find greater than 3. So 3 is the answer in this case. So I hope you understand the question. Now see how we will solve it. So see, basically what we are doing, we are moving one by one, and the moment our money exhausted, we will try from next. So this is where sliding window appears. So I have taken another case. In this he has money 12. Okay, he has money 12. So what he will do, he will start from first one and he can go up to here. So up till here sum is 10. 4 plus 3 7, 7 plus 1 8, 8 plus 2 10. He can afford. So up till here length is sum is 10. The moment he will try to include this horse, he will run out of money. So now you have to listen to carefully. So what I am saying that, suppose if I started from here and I understood that okay, afterward I cannot move. So now what we will do? Now we will try to move from second horse. So starting from first, we have found that this is the maximum I can go. So now there is no need to discuss further. Now we will see starting from second how far I can go. So now we want to start from second. So here what sliding window says that, now see, whenever I will start from second, again I have to find the sum. So 1 plus 3 4, 4 plus 4 8, and then we will see how far I can go. But sliding window, what it says, that if you have already found out the sum from here up till here, I have found out, and now if I know that I have to start from here and to find sum up till here, so no need to recalculate all the things. If I have the sum from here to here, it means I also have the sum from here to here, because this is just a part of it. So what we will do, we will reuse the values. So I have calculated the sum from here to here is 10. So if I have to find sum from here up to here, I will just minus this sum, minus this number. The moment you will subtract this number, so 10 minus 2, 8, you will get sum from here up till here. And you can see also 4 plus 3 7, 7 plus 1 8. So this is the sum. Okay, so this is sliding window. Initially the window was from here to here, and now I have slided that window and moved it from here to here. So this is called sliding window algorithm. Now with the help of this, no need to recalculate. So within one loop we can solve. So we have the sum up till here, and now we know that we will start from here. So again no need to recalculate the sum, just I will subtract this number and we will get the sum up till here. So now I have sum up till here. Now just I will try to add another horse. So up till here the sum is 8. Now I will just have to see whether by adding this number still I can afford or not. So 8 plus 4 is 12, which is So I cannot afford because I can only go up to 11. So see how simple it is. Next, what we will do? We will try from here. So again, we have all the sum. Just remove this part and we will get the sum. So this is the method of sliding window. Okay. So we will start from here, go up to somewhere. If it is not, after calculating this, now we will start from second horse. And to get the sum, I will just remove this part and we will have the sum. Okay. So I hope you understand. Now we will see how to code this. So let us see the code a little bit. So here we will discuss in C++. So I have this sum 1 in which I will store all the sum. This count which will store the length of the horses, how many horses we have gone up to. This is the max length, which is maximum length possible. Now we have taken the input n and k. After that, taken the input of all the horses prices. Now there is one for loop, and one by one we are trying to add our current number, and we will see if our adding this number, if still it is less than k, it means we can afford this. So I will add this to our sum and increase the count. If we cannot, by adding the number, if it is not less than k, it is greater than k, then we will remove our one number, that is last number, and we will add new number. So we will see one by one all this thing. Okay. So let us see. So Bob will think, okay, I will start from first horse and let us see how far I can go. After I finished, then I will start from second horse, then third, and so on. So when you will start from first horse, you will see, okay, if I include this in my sum, can I afford this? So 0 plus 30 is less than 100, means less than equal to 99. So I can afford this. So I will add this one. Now our sum will be 30. And the count will be 1 because one length is there. And max count still, now it is 0. So at last we are checking. If count is less than max count, means max length, so this count will be our new max. So since count is 1 and max length is 0, it means max length will be 1. Now we will see, Bob will see, okay, now I have sum 30. If I include 40, can I afford this? So 30 plus 40 is 70, which is less than 100. So yes, I can go ahead. So now the sum will be 70. And we'll include this also. Now the count will be 2, max length will be 2. Now we will see, okay, now I have spent 70 rupees. Now if I try to put the bet on this horse also, so 70 plus 50 will be 120. So I cannot afford. So the moment you will find that, okay, he cannot afford, so what we will do? We will try to remove some elements. Okay, so which one we will remove? So starting from here, we have gone up till here. Now as I told you, after starting from first one, we will next start from second one. So I have to remove this sum 30. Okay, so that thing we are removing. A of I minus count. So I minus count basically give us this, A of I minus count. So now we are looking for this horse. So I is 0, 1, 2. 2 minus count is 2. So 2 minus 2, which is 0. So A 0, this one. So can you see this element only we are removing? This is the way to write it. So we will remove this element 30. So now I wanted to start from here. So now we will remove this. So the moment I will remove this, our sum will be 40. So this is our new window. We can see this. Now we have only this one. And we will add current one also. Okay. So this now is our new window. So 40 plus 50, 90. And length will remain to be 2. You can see one element we are removing, one adding. So length will remain 2. Now this is our new window. Now we will try to move further. and we will see, okay, can I include this? So 40 plus 50, 90, 90 plus 20, 110, which is not possible. The moment we find that it is not possible, again we will remove our last element. So in this window the last is 40, so 90 minus 40, which is 50, and we'll add a new one. So this will be our new window. I will remove 1, we'll add 1. So now our sum is 70, and the length is 2 itself. Now we will see, okay, can I include this? So 70 plus 20, 90, which is less than 100. So I can include. The moment I will include this, our count will increase to 3. Max count will also be 3. Okay, so can you see? This is the maximum possible now. Similarly, we will keep on moving. So up till here in the new window, the sum is 90. The moment I will include this, I will check, okay, can I include this? So 90 plus 10, which is 100, which is not less than 100. So I cannot include. Again we will remove this. Again we will, this will be our new window, and we'll keep on going. So I hope you understand. So in this way, the maximum will be 3. Okay, that we will print. So I hope it is clear. Let me run few test cases, then we will conclude. Okay, so 10, 100. Try our sample one only. So 30, 40, 50, 20, 20. 30, 40, 50, 20, 20. 10, 90, 10, 10, 10. Okay, we got the solution as 3. So you let me try some more also. So let us take 5 elements and sum as 100. 1, 2, 3, 4, 5. Okay, you can see in this case answer is 5, because I can put bet on all the horses because I have enough money. 1 plus 2, 3, 3 plus 3, 6 plus 4, 14 plus 5, 15. So we need only 15 rupees. I have 99 rupees. So in this case, length will be 5. So you can try your own test cases. I will put the code in the comment section. And at last, let us conclude the code. So the code is simple. We will try checking after adding the element, still the sum is less than k or not. If it is, we will add, and if not, we will remove our last element and we'll add our current element. And why sum 1 not equals to 0? Because to suppose this is basically given so that for the initial elements, suppose there is one case in which I have suppose only one horse and I have only 10 rupees and the price of horse is 100 rupees. So in this case there is only one horse. So how can I remove the last one? Because there is no last one, because count is still 0. Okay, so I cannot remove. So for that only this is given. There is nothing else. Everything is same, just this is given to so that there is no some error, compile error or anything like that. Okay, so this is the code all about. I hope you understand, and try to go through the problem again, and if you have any problem in any part of the code, you can ask in the comment section. Okay, so this is all from my side. Thank you guys, take care.